Today, I'm going to show you how to make your terrain render even faster. Let's go! Alright, so we're in the middle of a series of videos on terrain rendering. In the last episode, I showed you how to use an array texture to reduce the number of texture samples your terrain is doing to make it render faster. If you missed last week's episode or any of the rest of the videos in the series, I've linked the playlist down in the description so you can catch up. Today, I'm going to show you how to apply another technique to make terrain rendering even faster than we made it last week. Now, normally on the channel, I show things in both Unreal and in Unity, and I try to make things as similar as possible between the two engines. In today's video, the features that I'm showing work a little bit differently between the two engines, and so what I'll be showing will be a little bit different. But the core idea is the same, and I'm going to explain the core idea here first, and then I'll show you how to implement it in both Unity and then in Unreal. So here's the core idea. Right now, we're using this fairly complex shader here. Let me just kind of zoom out and frame it up. Yeah, so we're using this fairly complex shader, and we're rendering it every frame. And what I want to do instead is render this shader just once and store the result in a large texture, and then make a separate, very simple shader that just samples that one texture every frame, instead of rendering the whole thing. So the shader that's running every frame is as simple as possible, just sampling one or two textures. And then we only run this complex version of the shader when we need to update things. So if something changes, for example. So that's the core idea. In Unity, it's called a base map, and in Unreal, it's called a runtime virtual texture. But I hope you see that the idea behind these is the same. All right, so I'm going to show you how to set it up. I'm going to show you how to set up both of those today in this video, starting in Unity. All right, so like I said, in Unity, this feature is part of the terrain system, and it's called a base map. When you create a shader that's using the terrain lit target, here's our terrain lit target here. That shader automatically, like under the hood, creates a couple of different versions. If we look at our shader graph asset down here in the project window, you can see that I've got two shaders associated with it, and those get generated automatically. This second one here is called base map gen, and that's indicating that the purpose of this shader is to generate that base map texture. So let's take a look at how this system works. If we select our terrain here, and we switch over to our terrain settings panel, I can come down here and there's this setting here called base map dist. And what that is the terrain is actually rendering two different versions of itself. It's rendering the very detailed version close up, but then far away, it's rendering just the base map version. So if I set my base map dist value to 0, now you can see that right here up close, and no matter how far away I am, it's rendering just the base map version of the shader. And so what's happened is under the hood, it's rendered my complex version one time and stored that in a texture. And now I'm using a very simple version of the shader that just samples that one texture. So this version of the terrain is rendering very, very fast because all it does is sample one texture and put that on the terrain. But as you can see, it's not very good. It looks pretty ugly. So the first thing that we're going to want to do is improve the resolution. So the idea here is, let's see, if I just set this to like 5, for example. So now you can see that here in the foreground, it's rendering the really fancy, expensive version of my terrain shader. And then back here in the background, it's switched and it's rendering the cheaper version. So, and then as I move away, yeah, now the whole thing is rendering the cheaper version. But then as I move in, it's rendering the more beautiful detailed version. Okay, now obviously this hard line here is a completely unacceptable artifact. And the fact that that terrain in the background is very low resolution is kind of a problem, because there's such a big jump between this detail version in the foreground and kind of this very simple version in the background. So what we want to do is, in order to improve performance on our terrain, we want to find a way of rendering this background shader on as much of the terrain as possible without it looking too ugly. And so right now we've kind of identified two things that are ugly looking. We have this hard, ugly seam between the two versions, and the texture resolution on our base map is too low. So first, let's talk about the texture resolution of the base map. If we scroll down our settings here, we can come to our texture resolution settings. And the last one in the list here is base texture resolution. Right now, it defaults to just a value of 512. And so if I drop this down and set it to 4096, now you can see that the resolution has increased significantly on our base texture. And there's a lot less difference here between the resolution of the background, the base map, and the foreground detail. And so this is what we want to do. Now, what happens is this 4096 by 4096 texture is applied to the entire terrain. So if I zoom out here, you can see that my terrain is a width of 100 meters and a length of 100 meters. And so I have one 4096 texture for this entire chunk of terrain. And that's why it's still fairly low resolution when I zoom in here, because it is a 4096 texture, which is pretty big, but it's also being applied to the entire size of my terrain here. So all of that texture resolution, but it's fairly spread out over a large distance. In order to manage that resolution, I think when I create a new terrain asset like I have here, it comes in with a terrain that has a width of 1,000 and a length of 1,000. So that's kind of the default size. But in my opinion, if you have a really large area of terrain, it's much better to build that terrain out of a whole bunch of smaller chunks. So I can make small chunks that are 100 by 100 instead of one chunk that is just 1,000 by 1,000. And that way, each individual 100 by 100 chunk can have its own base texture with a higher resolution than if I tried to, if my terrain was 1,000 by 1,000, then my base texture resolution would be spread over that entire chunk, and it still would be pretty low resolution. So when I make terrain, I like to keep the individual chunks small and then increase the size of my base texture resolution so that I can get some fairly high detail, and so that the contrast between the foreground and the background is smaller. And Unity's terrain system has a really nice feature built in for managing chunks. If you want to create a very large terrain, you can make a whole bunch of individual chunks and it will kind of sew them together, and there's a really nice system for managing those chunks. We're not going to go over that today because that's kind of outside the scope of the video. But the point that I want to make is you're probably going to be best, it's probably going to be best if all of your terrain chunks are relatively small. And one of the reasons for that is so that you can have a nice high resolution base texture. Okay, so by increasing the resolution of our base texture, we've brought it fairly close to the resolution of our detail texture. And so as I zoom out here, you can see that we still have this hard line, and that's the second thing that we want to fix. So let's go ahead and take a look at our texture here, at our shader here. This is the one that we created last week that does the array dithering. And right here at the end, we're unpacking our material into color, normal, metallic, smoothness, occlusion, and height. And what we want to do, instead of using that unpack material node, is use this distance fade node. Now let me explain what this node is going to be doing. If we take a look at our terrain here, let me just maximize this. And let's take a look at the individual channels of our terrain. So if we come up here in our menu and go to Analysis, Rendering Debugger, I can use this rendering debugger to take a look at the different material channels. So if we come here and pick albedo, this is going to show us just the color channel. So you can see that there's this nice, there's a line here where we go from really high resolution to our low resolution base texture. Now, one thing that's really important for me to explain is the base texture pass only has one texture, and it's going to be doing color and smoothness, but it doesn't have normal and occlusion. So if we look here, if we switch to smoothness, you can see that we're blending from like the high resolution smoothness to the low resolution smoothness there. But if we pick ambient occlusion, here's where our hard seam starts to play a part, because we have this nice ambient occlusion in the foreground material, but the background material's ambient occlusion is just white. And the same thing is true for our normal map. If we take a look at our normal map, the foreground has some nice crunchy detail in the normal, but the background, the normal map is just flat. And there's this hard line here, this edge, where that transition happens abruptly from a nice detailed normal to a completely flat normal, and nice detailed ambient occlusion to white. And so those factors contribute to this hard line. And so what we can do, and I'm just gonna leave this on our ambient occlusion view so that you can see what happens when we kick in our distance fade node. So the distance fade node, if you've downloaded the samples that come with Unity 6.3, you'll have the distance fade node. But let me just show you really quickly what it's doing. So we bring in our material and we unpack it into its individual channels. And then and then we lerp between a normal and our foreground normal and a flat normal. So that's what we're doing here. So we take our normal and we lerp between that and 001, which is a flat normal, using this distance mask. So the distance mask is like how far from the camera are we? And we have these two input values, distance fade start and distance fade length. So we're able to specify where that fade is taking place. And we do the same thing with the ambient occlusion. So here we're passing in the ambient occlusion from the foreground material, and then our second value is just 1, white. And we're able to do a smooth blend based on our camera distance. So let's go ahead and wire this distance fade node in. I'm just going to connect up our material, and then we're going to pass out our color, our normal, our smoothness, and our occlusion. And we're going to be able to use this to take care of that hard line. So if we take a look at our scene here, we've set our base map distance to 5, and that may be a little bit too close. We may want to push it back just a little bit, but the lower that we can make this base map distance and get away with it, the better the performance of our terrain is going to be, because we're going to be rendering more of the screen with this simplified background version of the shader and not this more expensive foreground version of the shader. So we've set it to 5. And so what we need to do is set where we want that fading to start. And for now, let's just set the fade to start at 2. So 2 meters away from the camera, we're going to start fading things out. And then our distance fade length we'll set to 3. So our total between our fade start and our fade length is going to equal this base map distance here. All right, so I'll save that and we'll switch back to our scene. And now you can see the whole thing is white. And that's because we're fading out that ambient occlusion. Now, if I get close to the scene, we're fading back in. And so here up close, we've got our detail texture. But as we move away, we fade it out. So instead of having a hard line, there's a smooth transition between our detail in the foreground and our white solid color in the background. And the same thing is also true for our normals. So if we switch our normal view here we have our close-up, high detail view of our normals. And then as we move out, we slowly and smoothly fade those into our flat normals. And so we're able to get a smooth transition. So let's set this to our regular view. And now, do you remember how there was that hard line? Well, now our hard line is practically erased because we're no longer doing that really fast, hard transition that we were doing with our normals and with our occlusion. And so we're able to get away with switching from our background rendering and our detailed foreground rendering without seeing a hard line. And so this will enable you to create terrain that renders really fast because you can set your base map distance to something low and then use this distance fade node to fade between the foreground and the background before getting that hard line. So now if we set our base map distance to, let's set it to something like 10, and then tune our shader here. Let's set our fade start to 5 and our fade length to 5. And now I think this is a very reasonable trade-off. So as we zoom out, you can see we're switching to the base map distance, but you hardly see that switch at all because we've made it smooth and we've made a nice distance between or a nice fade between our foreground and our background. So this would be a really good setting. So back here we're using our background shader that renders really fast, and then here up close we're using our foreground shader that renders more slowly but also has some really nice detail. All right, so that is a great way of making your terrain render super fast in Unity. Now we're going to switch over and I'm going to show you how to do something similar in Unreal using something called a runtime virtual texture. Okay, here we are in Unreal, and just like we did in Unity, I'm going to show you a way of making your landscape or terrain material render really fast. And the way that we're going to do this in Unreal is called a runtime virtual texture. And so the idea, kind of like I explained before, the idea is that we're going to take our complex material that we created for our terrain. Here's our terrain shader that we created last week. And we made this render as fast as possible by using an array texture, but it's still doing 6 texture samples and quite a bit of math. And so doing this rendering every frame is expensive. And so the idea that we want to do here is we want to take all of this complexity that we're rendering and render it into a virtual texture. And then every frame instead of doing all of this, we're just going to sample the virtual texture and that's it. And so the resulting shader will be a lot less expensive to render every frame. So what we need to do in order to set this up is create a volume that goes into our scene. And I've already done this, but let me just show you how it works. So I'm going to come up here under Window and choose Place Actor. And then I'm going to type in the search here, runtime, and I'm going to add a runtime virtual texture volume. All right, so I've already done that. And here's my runtime virtual texture volume. And I've aligned it with my terrain. And what I've done is just encapsulate the area of my scene where something is actually happening. So I have a bunch of terrain kind of outside where nothing is happening, but I've just made a volume and surrounded the area of the terrain that I really care about. We have some extra terrain out here, but I don't really care about that part. And so basically, in the transform, I just set my scale to 30,000 on the X and Y, and then 4,000 on the Z. So I'm basically just surrounding and encapsulating the area of my terrain that I really care about. And it's important that you make this thing the right size. If you make it way too big, then you'll end up wasting resources. So you want to make your volume surround just the area of the map that you care about. Okay, and the next thing that you want to do is create an actual runtime virtual texture. So I'm going to come here to my terrain shaders folder, and I'll just right click and pick texture, runtime virtual texture. And I'm going to call this texture, or this new asset, terrain RVT, and hit enter. And now I'm going to double click it. And you can see there's a couple of settings here. Size of the virtual texture in tiles. This is kind of like the resolution of the texture. And we'll come back to this in a minute. I'm going to show you how to set everything up. And then I'll show you how we can adjust this. Now here we can adjust the format and what's stored in the texture. You can see that by default it's set to base color, normal, roughness, and specular. And we're just going to stick with that. But if there's extra data you want to store, you can pick different formats for how the data is stored here. YCOCG is an alternate method of how to use the texture space to store the data a little bit more compactly. But we're just going to stick, for now, we're just going to stick with something simple. Base color, normal, roughness, and specular. So I've got my terrain RVT. I'm going to save it. And now I need to select my runtime virtual texture volume and assign that texture that I just created. So I'm going to drop this down and pick terrain RVT. So we've plugged our texture into our volume. And now the third thing that we need to do is tell our terrain to actually render into the texture. So I'm going to select our landscape object here and scroll down my settings to virtual texture. And there's this place here called draw in virtual textures. So I'm just going to hit this plus, and then I'm going to select the virtual texture that I want it to draw into. Okay, so now I've assigned my terrain to draw into my virtual texture, and I've scaled my bounding volume, or my RVT volume, to be the right size. And the last thing that I need to do is adjust the material that's on my terrain to tell it to write into the virtual texture. So here's the material that we created. And right now, all of the wires or the results of the material are being passed into kind of our output node here. And what we want to do instead is pass them into the runtime virtual texture output. So this node becomes kind of like a replacement for this main node here. And so what I can do is just instead of wiring things into my main output node, I can wire them into this node instead. And what that'll do is it'll tell the material, hey, instead of rendering into the landscape, I want you to render your results into this runtime virtual texture. And so all we need to do is just take our wires that we're going into our main output node there, and I'm going to wire them into our runtime virtual texture output instead. So I'll wire my color, and I'll wire my roughness, and I'll wire my normal. And I have ambient occlusion here, but instead of wiring my ambient occlusion into the ambient occlusion output, I think what I'm going to do is take my ambient occlusion and just multiply it by 0.5. And then I'm going to wire that into the specular so that I can dim down my specular highlights. Okay, so let's save this and take a look at what we get now. So if I take a look at my content drawer, yeah, now you can see that my terrain RVT actually has a nice little preview here indicating that my terrain data is going into the runtime virtual texture. So now I actually need to use that runtime virtual texture in my terrain material. So right now, my terrain material is doing something kind of interesting. It's actually writing out to my landscape or my terrain, and it's writing out to the runtime virtual texture. So it's doing both. But what I want to do instead is the data that's going out to my landscape, I want to read from the runtime virtual texture. And so let's add that node. So I want to add a node here called runtime virtual texture sample. And what this is going to do is whatever is being written out to my runtime virtual texture here, this node is going to sample it. And then I can just pass that out to my my output node here. So I'm going to connect up my base color, my specular, my roughness, and my normal. And I'm just going to disconnect the ambient occlusion because we don't need that. So now what you can see is I actually have two materials here. I have this material that is sampling my runtime virtual texture, and I have this material over here that is writing into the runtime virtual texture. So I've actually got two materials in one in this graph here, which is really interesting. Now the cool thing is the way that the system works, this part of the material that's doing all of this complex work, it only gets run every once in a while when there's an update that's needed. So it's only updating every now and then. But this part that's going into the landscape is updating every frame. So every frame, we're sampling our virtual texture and rendering our landscape. But then the complex part of the graph here only happens every once in a while when an update needs to be made. Like when I'm moving around and it needs to update tiles, then it renders my landscape once into the runtime virtual texture instead of over and over and over, you know, like 60 or 80, however many frames per second. So this is an amazing way of saving on performance. Well, let's go ahead and save it and take a look at the results that we're getting. All right, now there is one step that I forgot when I was setting this up. When I'm writing out to the runtime virtual texture, I can pass it out to this node. But when I'm reading from the runtime virtual texture on this node, I need to specify which RVT to use. And that's right here. So I set the runtime virtual texture to terrain RVT. And now it's going to render into, it's going to render from that texture onto my landscape. So let's switch over to my scene and take a look at our results. Okay, here I am in my scene in Unreal, and you can see that my landscape is being rendered to the runtime virtual texture. And then at runtime, we're sampling that virtual texture and applying it to the landscape. And I actually don't see any problems here at all. Well, the one problem that I see is that it's maybe just a little bit too, the resolution is maybe just a little bit too low. And so what I can do is I can come here to my content drawer and double click on my terrain RVT to bring up the options. And right now, the size of the virtual texture in the tiles is 256. And I can just increase this to increase my resolution. So now, when I look at my results, my resolution is quite a bit higher. Now, doing that is going to increase the amount of memory that I'm using, obviously. So if I increase the size of the texture tiles, it's going to take up more memory. So I'm going to want to find a good balance between the amount of memory that I'm using and the resolution that I need on my terrain. The smaller that you're able to make your bounding box, the less memory you'll be using, and also the lower that you can keep that setting that I just adjusted, the less memory you'll be using. But what I'm doing basically is trading off using more memory for using less GPU calculations. Because what's happening right now is that the complex landscape material that I created here is all being rendered into that virtual texture, but it's not being rendered all the time. It's only updated sometimes, occasionally, not every frame. And so that's going to save me a lot of performance. And what it means is if I want to, I can actually make this landscape material here significantly more complicated because it's only rendered occasionally. It's not being updated every frame. So I can add a lot more complexity into this without it actually costing me much of everything. Much of anything, I mean, because I'm only updating that every once in a while. So this is a brilliant, really ingenious way of saving on performance and still being able to create really complicated, really beautiful landscape materials. All right, I hope this video was beneficial to you. I hope you enjoyed it and that you're able to follow along and create runtime virtual textures in Unreal and use the base texture in Unity to save on a lot of performance. Thanks for watching today. Have a good one, and we'll see you next time.